Hello and welcome to the Database Management System class. Myself Umesh Laktaria. In this video lecture, I am going to discuss about two-phase commit protocol. Two-phase commit protocol is used for system recovery in a distributed database management system. Here, all the works are distributed. So to handle that work, two-phase commit protocol is used. Here, for handling that work, there are two phases required. So here you can see two-phase commit protocol ensures that all participants perform the same action, either to commit or to roll back a transaction. As we all know that, as Atomic says, either transaction executes 0% or 100%. There is no any option for the partial transaction, right? So either transaction occurs 0% or 100%. So if the transaction is 0%, that means the work is not completed. If the transaction is 100%, that means the work is completed 100%, right? Then and then we can modify the data into the database. So two-phase commit protocol ensures that all participants perform the same action, either to commit or to roll back a transaction. It is designed to ensure that either all the databases are updated or none of them, so that the databases remain synchronous. At a time, we have to synchronize the data. If the transaction is 100% completed, then the database should remain synchronized. If the transaction is not completed successfully, then the database remain as well as that was before. In two-phase commit protocol, there is one node which is act as a coordinator or controlling site, and all other participating nodes are known as cohorts or participant or slave. So coordinator who controls the site, so the component that coordinates with all the participants. Cohorts, they are known as participants or slaves. Each individual node except coordinator are participant. So as the name suggests, the two-phase commit protocol involves two phases. One, that is commit request phase or prepare phase. Second one is commit or abort phase. So here in the diagrammatical representation, you can see there are 5 persons are available. One, that is coordinator, that is centralized person, and other 4 are participant. So the coordinator will request to the participants for prepare. So coordinator sends request asking for ready to commit. If the work divided among the participants is completed, then the coordinator sends request asking for ready to commit. Participants send reply whether ready to commit or not. If one of the participants from these 4 participants is not ready, then he or she will send acknowledgement according to their purpose. And if the work is completed by each and every participant, then they all are ready to commit the work, right? So here participants send reply whether ready to commit or not. Now the coordinator will inform to do commit. If all the participants are ready to commit the work, then now coordinator will inform to the participants to do the commit. Now send acknowledgement to inform whether commit done or not. Now the participants are ready to commit. If they have committed the work, then they have to send acknowledgement to coordinator to inform whether commit done or not. So here there are 2 phases. One is prepare phase. The phase starts from request to prepare to the prepare, that is known as prepare phase, and the phase starts from commit or abort to the done, that is known as commit phase. Now commit request phase is also known as obtaining decision phase. So after each slave has locally completed its transaction, it sends a done message to the coordinating side. When the controlling side has received done message from all slaves, it sends a prepare message to the slaves. So the slaves vote on whether they still want to commit or not. If a slave wants to commit, it sends a ready message. A slave that does not want to commit sends a not ready message. This may happen when the slave has conflicting concurrent transaction or there is a timeout. Now, commit phase, that is also known as performing decision phase. So after the controlling side has received a ready message from all the slaves, the controlling side sends a global commit message to the slaves. The slaves commit the transaction and send a commit ACK message to the controlling side. When the controlling side receives commit ACK message from all the slaves, it considers the transaction as committed. Now, commit phase, performing decision. So, the first phase that you know that you study, that is commit phase, performing decision. That is for commit phase, 100% commit phase. That means what, all the participants have committed their work. Right now, the second, the commit phase, performing decision, that is for one of the participant has not completed the work. That means what, is not ready to commit the work. So for that, after the controlling side has received the first not ready message from any slave, the controlling side sends a global abort message to the slaves. So the slaves abort the transaction and send a abort ACK message to the controlling side. So here you can see either transaction occurs 0% or 100%. So if any of the participants sends a abort message, then the whole transaction will be aborted. So global abort message will be sent to the slaves by the controlling side. But if all of the participants are ready to commit the work and all of the participants all of the participants have completed the work, then the commit ACK message, that means the acknowledgement, positive acknowledgement will be sent to the slaves and it considers the transactions as committed. So here you can see either transaction occurs 100% or 0%. There is no any chance of partial transaction, right? So we cannot say that 70% transactions is executed, 30% are remaining, right? Okay, otherwise database will be not synchronized and you will not see the reflected changes. When the controlling side receives abort ACK message from all the slaves, it considers the transactions as uploaded. So thank you for watching the video.